Okay. So the next property of acid is that we have discussed for the previous one, that acids when react with metals, they will give you what they will give you. They will give you salt
plus hydrogen.
plus hydrogen gas. Okay. The next property is acids when react with metal oxide, then what they will give you? They will give you salt instead of hydrogen gas. Now this will be water. This oxide will shift it to this one. Okay. Understood? The same product will be formed. For example, if we have this acids when react with that I'm having HCl, okay, plus ZNO, then it will gives you ZnCl2 plus hydrogen. Plus instead of hydrogen, now it will come water. Okay. The formula will be written accordingly. This is Zn and this is Cl. So formula will be written accordingly. Okay. Zn Cl2. Okay. Now you understand? This is one. This is going to have two valency. This is going to have one valency. So when you cross multiply, you will get ZnCl2. Okay. Got it? Here, students. So let's move further. That is HCl is here. Okay. Now moving. Now you can consider this one. This is acid. Okay. And this one is salt. And this one is water. This one is salt. And this one is water. So if I compare this one with general equation, what can be this, the nature of this zinc oxide? What
Base.
will it be? Yeah, it will be base, because you know very well acid when react with base gives you salt plus water. So we can say that, we can write here important point, that generally metal oxides are basic in nature. Basic in nature. Okay. Done? Should I move further, Jovita?
Yes, sir.
Okay. The metal oxides are generally basic in nature. The next property of acid is acids when react with metal carbonate. What is metal carbonate? Metals, and the carbonate group is actually carbonate group is actually CO3. Okay, got it? Carbonate is actually CO3. So if I say that this is carbonate group, okay, when it is attached, CO3 minus 2, and it is attached with metal, so it will form metal carbonate. Okay, it will form metal carbonate. Got it?
Yes,
So now if I'm having this one, let's suppose if I'm having magnesium and this is carbonate, okay, and then this is metal and this is carbonate group. So when they join together, they form a compound that is MgCO3. Similarly, sodium is metal and this is carbonate group. This is going to have two valency. It is going to have one valency. So when this cross multiply, we'll get Na2CO3, sodium carbonate. So when acids react with metal carbonate, they form salt plus carbon dioxide plus water plus carbon dioxide gas. Okay, instant of carbon dioxide is released. Okay, you understood? Okay, now moving to the next point here is that, for example, if I'm having acid, like I'm having HCl when react with, let's suppose if I'm having HCl react with sodium carbonate, Na2CO3. So what is going to give you? This is water plus carbon dioxide will be formed because it is the general equation. Now tell me what should be here? The type of salt that is formed. Name the salt.
NaCl.
This will be NaCl. Okay. Now you can write Na2Cl. Okay. Because here are two. Don't write it like this way. Okay. You have to write the proper formula, that is NaCl. Okay. The formula for NaCl. Okay. Understood? Got it?
Sir.
Okay. Now moving to the next point here is, so if I'm writing the next equation is Ca, that I'm having this H2SO4 when react with calcium carbonate, what it will gives you? What it will gives you?
CaSO4
CaSO4 plus
plus H2O plus CO2.
got it?
Yes,
Understood?
yes, sir.
Okay. So this is the property. Now the property that we have done, acids when react with metals, acid when react with metal oxides, acid when react with bases we have done, acid when react with metal carbonate. Instead of metal carbonate, it can be metal hydrogen carbonates also, okay? So the same result will be formed. Means acids when react with, instead of metal carbonate, they can also react with metal hydrogen carbonate, okay? So instead of metal carbonate, they can react with metal hydrogen carbonate also. And what is hydrogen carbonate? Hydrogen carbonate is SCO3 minus 1. This is the hydrogen carbonate group. Hydrogen carbonate group. Okay. So when we have Na and we have HCO3, they togetherly when combined to form a group salt that is called metal hydrogen carbonate. Okay. This is metal. And this one is hydrogen carbonate. So when they combine together, so for example, we have Na, valency 1, HCO3, also valency 1. So they togetherly form NaHCO3. Okay. Like we have magnesium here and we have HCO3 here. So it is 2 valency, it is 1 valency here. We cross multiply it, we'll get MgHCO3. And this will it comes in the whole bracket, that is 2. MgHCO3 whole twice. Okay. Got it. So when metal hydrogen carbonate also, so it gives the same results. When acid react with either metal carbonate or metal hydrogen carbonate, the result will be same. So acids when react with either with metal carbonate slash metal hydrogen carbonate, we have the same result, that is salt plus carbon dioxide plus water. For example, if I'm having HCl when react
Sir,
with Na2CO3.
sir,
Yes. Yes.
sir, is it salt plus H2O plus CO2, right?
Yes. No, you can write it. It is not necessary. You can write it like this. It is not, means the product should be same. You can write here to, it is not necessary. Okay. You
Okay,
can write H2O plus CO2 plus salt. You can write it salt at the end. Okay. It's not necessary
okay,
that you have to write. There is no sequence is being required. Okay. For writing this one.
okay.
Now, if I'm having, this is sodium carbonate. This I have written, this will give you NaCl plus CO2 plus water. And if you have HCl, when react with NaHCO3, it will again give you the same salt NaCl plus carbon dioxide plus water. But there is a difference of balancing only. Okay. For example, here you have 2 Na and you have only 1 plus, so you have to multiply this one by 2, this one by 2, to 2H, 2Cl, 2Cl, 2 Na, and 1 CO3, CO2, and 1 oxygen here. It is balanced. Okay. Similarly, here it is already balanced. 1 Na, Cl, 1 hydrogen here means 2 hydrogen, and 1 carbon dioxide and 1 oxygen. This will give you CO3. Okay. So this is balanced. So here we have, there's a difference of balancing. Okay. Otherwise, the salt will be obtained. Means same product. Tejasvi, where were you? Why you joined late?
Sorry, sir. Actually, I had some internet issues. Sir, can you hear me?
Done?
Yes, sir.
Okay. So we have done all the properties of acids, that acids when react with metals, acid when react with metal oxide, acid when react with base, acid when react with metal carbonate, metal hydrogen carbonates. Okay. Do acids also react with non-metals
No,
to produce hydrogen gas?
acids will react with metals.
Only. Why do they don't react with metals, non-metals?
They do not produce H2 gas.
Okay. If I'm asking, do acid also react with non-metals? So we will say no. No, acid do not react with non-metals. Okay. Why? Why? What is the what is the reason behind this one? So let me explain you. Nobody is going to ask you the question. Let me explain you a simple question. Because you know this is HCl. Okay. When it is going to means when it is added to the water, then it will gives you gives you H positive and Cl minus ion. The H positive ions means the hydrogen atom when it is, you know that the hydrogen atom is going to have only one electron in its outermost shell. Only one electron. So when it loses one electron, it becomes the hydrogen ions. Okay, without an electron. Got it? So for becoming the hydrogen gas, for hydrogen, this hydrogen ions, and hydrogen gas is just like this. With one electrons, both two atoms, they combine together and they form H2 gas. So for formation of H2 gas, we need electrons. And metals are good donator of electrons. Metals can easily donate electrons. Okay, for example, if I'm having magnesium is going to have Mg 2 electronic configuration. So if there are two hydrogen ions, so one electron will be going to this one electron will go into this one, and it will form hydrogen atoms, and these hydrogen atoms togetherly make hydrogen gas. So metals can donate electrons. While if instead of magnesium, if let's suppose there is nitrogen, or let's suppose there is sulfur 286, so it cannot donate the electrons because it needs the electrons. Sulfur need 2 extra electrons. So sulfur itself need an 2 electron, means sulfur is actually electron deficient. It does not donate the electron to the hydrogen ion to form hydrogen gas. Okay, so we can simply say that no, acid do not react with nonmetals because nonmetals are electron deficient. We will simply say no, acid do not react with nonmetals because acids are electron deficient. You went to school today, Yovida?
No, sir, today we are having holiday because of Onam,
Because of
the festival Onam.
this festival season going on there.
Yes, no, in Kerala there is Onam, right?
Okay. In Kerala there is Onam. Okay.
And so we are having right now online classes.
Okay. But you live in Saudi Arabia, na? So say for that you are studying there in Kerala school specifically.
No, like international school, right? So they will be giving all the holidays.
Okay. I understood. So today is Onam, na? Means Onam how can you tell me that for how many days this festival goes on?
10 days.
10 days. It's fine. Very good.
Today is the last day.
Today is the last day. Okay. So we have this one. So okay. No, acid do not react with nonmetal because acids are electron deficient. Okay. Because nonmetals are because you have to write here nonmetals. Okay, I've just write something. You have to write here. I write it again. No, acid do not react with non-metals because
Done, sir.
Done, everybody? Shweb, Tejasvi? Shweb and Tejasvi?
Yes, sir.
Done?
Just a minute, sir.
Yes, sir.
Okay, now the next property of acids. Let's start with the next property of acids. Let's, you know that acids do not react with non-metals. Okay, so they react with non-metal oxide? So they are not going to react with the non-metal oxides also. Okay, or will they react? Okay, let's discuss first. Let's discuss the chemical properties of bases. Then we're going to discuss this one. Okay, chemical properties of bases. Okay, just I'm going to compare it with the acid also. Okay, so you know that acids, when react with metals, it will give you salt plus hydrogen gas. Similarly, bases when react with metals, they also gives you salt plus hydrogen gas. Okay, but there is terms and condition. The base must be strong base. Terms and condition for this one is strong base. Base must be strong base. Strong base like NaOH. NaOH. Okay, and metals will be like this. Generally, these metals: zinc, lead, aluminium, zinc, lead, aluminium. Okay. So note it down. Tejasvi?
Yes, sir. Can you hear me?
Yes, I can hear you.
Sir, actually, I have been answering for your questions, but I guess my voice wasn't audible to you.
Okay, okay. So you can turn on your camera so that I can see you whether you are saying something, you are speaking. Okay. That's why.
Okay, sir.
Okay,
Okay,
that's
sir.
Done, sir.
done. Okay. So let's move further. Now, this is very, very important. I'm going to give you the question regarding to this one. Okay. So if I'm having this sodium, let's suppose I'm having this sodium hydroxide, this is base, when react with zinc. So it will gives you zinc oxide, sodium zincate. This is an important salt that hydrogen gas will be produced accordingly. This is base. This is metals. When react with this will produce hydrogen gas, and the salt here form will be sodium zincate, Na2ZnO2. Okay. This you have to remember the formula, the correct formula, that is sodium zincate. Okay. Got it? Similarly, if you have NaOH, when react with lead, so it will form you Na2PbO2 plus hydrogen gas, and this will give you sodium plumbate. And the next one is NaOH, when react with aluminium, it will gives you NaAlO2 plus hydrogen gas. Okay, here there is no 2. Okay, here in this sodium Na2, but here is no 2. Okay, no 2 is written here. Okay, NaAlO2. The correct formula is NaAlO2, and this is called sodium aluminate. Sodium aluminate. Note it down.
Done, sir.
Okay, done. Jovita, where have you gone, Jovita?
Sir.
Okay, done.
Yes.
So now speaking to this one, this is very important that you need to understood here. Sodium when react with zinc, it will give you sodium zincate plus hydrogen gas. Na when react with lead Pb, that it gives plumbate. Plumbate, why? Because Pb is the means as we have sodium. Sodium is Na, but its name is natrium. Okay. Similarly, plumbate, Pb, lead is the lead's the name of lead was plumbus. Okay, so from that it comes plumbate. Okay. Okay, and you need to keep in mind that this is very important. Okay, now moving to this one, instead of sodium, and I'm going to, this was just metals will react with base. Now if we have metal oxide instead of this one, if we have metal oxides, so now again base when react with metal oxide, base when react with metal oxide, it will again give you salt plus water. What it will form? Plus salt plus,
Water.
yes, it will be water. Okay, if we add oxide here, then it will become water. So if I add the oxide here, that if I'm having ZNO, PbO and Al2O3, then it will become H2O, this one and this one. Okay, note it down again. Note it again. Done?
Yes,
So,
sir.
Hmm?
so I'm writing the last one.
Okay.
Done, sir.
Done. Okay. So let me ask you a simple question here. That you know that acid, we were studying that this one. Acid when react with base, it will give you salt plus hydrogen water. Okay. And you know that acid when react with metal oxide, it gives salt plus water. Now bases are also reacting with metal oxide. It is also forming salt plus water. Acid when react with base, it's so salt plus water. Acid when react with metal oxides, it's so salt plus water. Now again, acid when react with metal oxide, it again gives you salt plus water. So here when I was just teaching this property to you recently, so I told you that if acid when react with metal oxide, it is forming salt and water. So I told you that metal oxide is showing here the behavior of base, basic behavior. The basic behavior. And here you see that this is base when react with metals again. So here base plus base will not give you salt plus water. So here it is showing the property of acid, because acid plus base gives you salt plus water. So metal oxide is showing here acidic behavior. Okay, you understood? Sometimes the metal shows. So for example, if I'm having this H2SO4 when react with ZNO, it will give you ZnSO4 plus water. And similarly, when NaOH react with ZNO, it will give you Na2ZnO2 plus water. So here we are going to have both of them are going to have acid plus metal oxides. Here you see this is showing the basic behavior, and here it is showing the acidic behavior. So note it down first, then I will write this statement. Okay. Done.
Yes, sir.
Should I
Yes,
move?
sir.
I'm done.
No, sir, just a minute.
Okay, write it.
Done, sir.
Done. Okay. So let's move further, dear students. Now, if I'm having, you see that here the metal oxides are behaving acidic as well as basic behavior. Okay. So you need to keep in mind here that not every time metals, metal oxides are showing the basic behavior. Generally, they show basic nature. Metal oxides are generally basic in nature, but sometimes they also show the acidic behavior. So some metal oxide shows only. Not every metal oxide is showing the basic as well as acidic behavior. Okay, some metal oxides show both acidic as well as basic behavior, and this type of metal oxides is called, what we called it, amphoteric oxides. Okay, understood?
Yes, sir.
Got it? So we have to write here that some metal oxide show both acidic as well as basic behavior. Some metal oxide show both acidic as well as basic behavior. Such metal oxides are called amphoteric oxide. Note it down. Abir, why are you late?
Sir, I thought the class was going to start at 7:30, so I slept.
They were written as 7:30.
No, sir, my previous classes were all at 7:30. That's why. I got the message. I got the correct message with the correct time, but I didn't see in the morning.
You didn't see it. Okay. So your half an hour class you have missed. So will you check it on your portal?
Yes, sir.
Yes, this is because it is important. This is the chemical properties of bases. That is very important. Okay. And otherwise we have to join. Let me check whether we are going to have the second batch class. You have to join the half an hour class in the at 9:30 in Indian, according to the Indian timings. Yeah, you have to join at 9:30. Okay, to study the same topic. Okay, that is important.
Yes, sir.
Wait a minute.
Done, sir.
Wait a minute. Let's do the question related to this topic. Okay. So here, students. Okay, tell me. Calcium phosphate is present in tooth enamel. It is basic in nature, acidic in nature, neutral, or amphoteric. Calcium phosphate. Are you doing your homework that I used to send you? calcium phosphate is present in tooth enamel. Its nature is basic, acidic, neutral, or amphoteric.
Basic.
Basic, sir.
Calcium phosphate, yes, basic nature. Let me explain you why. So in the previous class, when I was just teaching you, this one, when I was just teaching you, okay. So I told you that calcium hydroxide is a weak base, but it is not so weak that when it react with the weak acid like H3PO4, that is phosphoric acid. Okay, so when it react with, it will gives you calcium Ca3PO4 whole twice plus water. Okay, so this is weak base and this is weak acid, but in front of weak acid, it behave as strong base. I have especially asked you to write this statement in your copy. Okay, so this is Ca and this is calcium phosphate. This will be basic in nature. Okay, basic in nature. Okay, so because strong base. But if we have calcium, let's suppose if we have calcium hydroxide, and when it react with, let's suppose it react with H2SO4. Okay, now you know H2SO4 is a strong acid. So now in front of a strong acid, it behave as weak base. And it will be calcium sulfate, CSO4. This is acidic salt. Acidic salt. Okay, so this way we have discussed in the previous class. Okay, so note it down, note this question, note this statement here. Calcium phosphate is present in tooth enamel, which is basic in nature.
Done, sir.
Done. Okay. Let's do the question that we are studying on this topic. Okay. We have this question. You have seen this chart. Okay. Now let me take this one. Okay. Now you know that in the following systematic diagram, there is a method for preparation of hydrogen gas, and you are seeing this one, that zinc granules is added to the dilute sulfuric acid. There is dilute sulfuric acid present in it. Okay. Now let me have this question on the slide. Wait a minute, so that you can understand more betterly. Okay. 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 Now tell me this. I'm going to show you here. Now tell me, dear students, that this is the way of preparation of hydrogen gas. Okay. Now tell me, in place of zinc granule, if some amount of zinc dust is taken, then what is going to happen? If you take instead of zinc granules, the larger ball, if you take instead of zinc granule, if you take zinc powder, then what is going to happen? Will the hydrogen gas produce this time?
Yes, sir.
The hydrogen gas will be produced. Okay. Will it be at the same rate at the previous means, or will
No,
it,
sir.
No.
It will be less.
it will be at same less rate? Okay. Okay. If I ask you that if you are going to dissolve the sugar in water, if you have a bigger crystal of sugar and you are under and now this time you are having the bigger crystal of sugar and you are just dissolving it into the water. Okay. And now this time you have grinded the sugar and you have made it powder. Now you are dissolving this one into the water. Which process do you think that will help you to dissolve faster?
The powdered sugar.
Powder sugar. The powder sugar. Why? Because powder sugars, similarly we can say that here also, that if we want to means this zinc granules we are going to have. So when we convert this zinc granules into the powder form, then the more surface area will be increased. Okay. And more surface area, then more acid can react with the zinc instantly. For example, if I'm having a strip of zinc, okay, that I'm having the strip of zinc, then only the atoms that are present at that surface are going to react with the acid. So when we are having a strip, not every atom come in the contact with the we can simply say that with the acid. But if we powder it, if we are having the powder of zinc, then more number of atoms will come in the contact with the acid. So we can say that this time the hydrogen gas will produce, but at the faster rate than the previous one. Okay. Got it? At faster
Yes,
rate,
sir.
hydrogen gas will produce. Now instead of dilute sulfuric acid, if you take dilute hydrochloric acid, will the hydrogen gas produced? Will the hydrogen gas produce this time? Shoaib, why you left the class?
I got disconnected because of the internet.
Because of the internet, and it take more than 15 minutes to join again.
Yes, sir.
Okay. So if we have, dear student, if we have dilute sulfuric acid, so it is also an acid. So what is going to happen here is nothing. Initially, you know that HCl when react with if we have zinc when react with Zn H2SO4, then it will be what it will be forming. It will be forming ZnSO4 plus hydrogen gas. And similarly, if we have zinc plus HCl, now this will form ZnCl2 plus hydrogen gas. Okay. But here you have to balance this one too. Now this is balanced. Okay. So we can simply say that the hydrogen gas will be produced. Okay. Got it?
Yes, sir.
Now, if it is being asked in place of zinc, copper turning is taken.
No reaction will take place.
Yes, because zinc, because you know that copper when react with HCl, okay, or H2SO4, it is not going to react because copper is
Less reactive.
less reactive than hydrogen. So no reaction will take place. Okay, no reaction will take place. And for the question number D, instead of if it is being said that instead of H2SO4, if we take sodium hydroxide, the test tube is slightly heated, then will the hydrogen gas produce? Instead of HCl, H2SO4, we take the NaOH. Will the hydrogen gas produced?
No, sir.
Jobita?
Yes, sir.
No.
It will be produced.
Tejasvi is saying it will produced. Abir, will it be produced? Will hydrogen gas produced?
It will be produced.
And it will produce. Means bases when react with metals, They also produce hydrogen gas, huh?
No, sir.
No, sir.
No, no one produce hydrogen.
It means you are Jobita, you are not studying concentratedly. Yes, you are where is the concentration? I have taught you this one. This one. We were just studying this one. Acid when react with metals. This one. Base when react with. So I have taught you this one. Base when react with metal, they also produce salt plus hydrogen gas. But here the base should be NaOH and metal should be this one. So you know that zinc is present and we have the base NaOH. They, Jobita, you are saying something, but sorry, Tejasvi, you are saying something, but you have muted.
No, sir. Actually, I was just solving the equation.
Okay. So here we have simple the equation. This time the equation will be NaOH when react with zinc. It will gives you sodium zincate, Na2ZnO2 plus hydrogen gas. Okay. You got it? You understood? Tejasvi
Yes, sir.
and Jobita, now you understood?
Yes, sir.
Sir, I said it
Please
will
don't.
take the hydrogen gas will be formed.
Yeah, hydrogen gas will be formed. Okay. So if we take instead of H2SO4, if we take the NaOH, then it will be then again hydrogen gas will be produced. Okay. Got it? So please note the answer of these questions, all the questions. Okay. And make a rough, but you're not going to make, we don't have much time. So make a rough diagram. You have only 3 minutes to note the answers and make the rough diagram of this one. Okay. Fast, do it fast. Every student is requested to please join on time. If from the next class, I will, if the time is given 6:30 sharp, I will start at 6:30. Okay, not wait for any students because this is important. We are just going to have back-to-back classes. And if you are not attending the class on time, means you are missing because we need to end the class sharp at 7:30. Okay, so we have, at least we need to study 1 hour. Na? Syllabus is not so small. We have to study each and everything in detail. Okay.
Noted, sir.
Noted. Tejasvi, Jobita,
Done, sir.
done. Still writing, Jobita?
Yes, sir.
Done. Okay. Shoaib, done?
Yes, sir.
Are you sleeping? Turn
No,
on
sir.
your camera.
I don't have a camera right now.
You don't have the camera right now. Okay. This is the biggest problem in this. Otherwise. Okay. So we have done this one. Let's move further, dear students. So now moving towards the pH of the solutions. Okay. The basic property we have done for the first property was acid. We are just studying the chemical properties of bases. We have done base when react with metals. It will give you salt plus hydrogen gas. Okay. And base when react with metal oxide. Again, I told you this will give you salt plus water. You can check in your copy. Okay. And next, base when react with acid. Again, it will give you salt plus water. So this you have studied. Base when react with acids, it will give you salt plus water. We have studied this one also. Okay. Now, base when react with non-metal oxides. Non-metal oxides are acidic in nature. So we can say base when react with non-metal oxide. Non-metal oxide. And you know non-metal oxides are? Metal oxides are basic in nature. So non-metal oxides are acidic in nature. Acidic in nature. This is very simple that if we have base and we are reacting something with acid, so this will give you salt plus water. That's a simple answer. Okay. So if we have NaOH, we are reacting this with sulfur dioxide. So it will give you Na2SO3 plus water. Okay, you know to keep in mind here that whatever we have, if we are having sulfur dioxide, then here will be SO3, not SO2. If we have NaOH, when react with sulfur trioxide, then it will give you Na2SO4. The one oxygen will be added, okay, extra, plus water. Okay, this is sodium sulfate and this is sodium sulfide. Sodium sulfide. Na2SO4. For example, if I'm asking you NaOH, when react with CO2, what it will give you? Tell me. Na?
CO3.
Yes, Na2CO3. Na2CO3. Why 2? Why 2? Because CO3 is carbonate group. It is going to have 2 valency and Na is going to have 1 valency. So when they bond together, they will form Na2CO3. So this is important. Okay. Got it?
Yes, sir.
Yes, sir.
Okay. Now moving towards the pH of a solution. So pH, what is P? P means power. pH means power and H means hydrogen ions. But this power come from the Greek word that is potens. Potens, okay? And H means hydrogen ion concentration. Hydrogen ions concentration, okay? So what does pH? pH gives you. pH is a scale. pH is a scale that gives us information how acidic or basic a substance is. Okay. So we can write it. We have 7 here. We have 0 and we have 14. This one indicate, this range indicate acidic. This range indicate basic, and this range indicate 7 indicate neutral. Note it down fast. When you're done, please let me know. Okay.
Done, sir.
Done.
Done, sir.
Okay. Now moving further, Suppose if I'm having, I'm saying that this the pH of a solution is 2, then its hydrogen ion concentration will be 10 raised to the power minus 2. If I'm saying that as a substance has going pH 3, then the hydrogen ion concentration in that will be 10 raised to the power minus 3. Got it?
Yes.
If I'm having the pH of a solution is 7, then what will be the hydrogen ion concentration?
10 raised to minus 1.
10 raised to the power minus 7. If I'm
Minus
having a pH 10, then it will be going to have H plus ion concentration
10 raised to minus 10.
10 raised to the power minus 10. If it is 12, then it will be 10 raised to the power minus 12. Okay, and so on. Got it? So if there is a question in the NCERT, do the basic solution also have H plus ions concentration? Okay, now you need to keep in mind here one thing is that if the H plus ion concentration, if the pH of a solution is 10 raised to the power minus 2, okay, then OH ion concentration in that solution will be OH ion concentration in that solution will be. So let me explain you one more time this one. So if I'm saying the pH is 2, then the hydrogen ion concentration will be 10 raised to the power minus 2. But you know that if the product of, this is important that you need to understand that the product of H plus ions and the OH minus ion is always 10 raised to the power minus 14. So if we have 10 raised to the power minus 2 as H plus ion concentration, then the OH ion concentration in the same solution will be 10 raised to the power minus 12. It is constant. This is called water product or KW product. Okay, KW. It is always a solution must have H plus ion and OH ion concentration as 10 raised to the power minus 14. The product of this one and this one should be 10 raised to the power minus 14. Okay, this is an NCERT question that I'm going to explain you one more time. Okay, because the question is being asked in the NCERT. Do the basic solutions also have H plus ions? So according to you, you say that H plus ion indicate the basic behavior, sorry, acidic behavior. So what is H plus ion doing in the basic solution? So you can simply say that no, bases do not have H plus ions. Okay, you can simply say that now, because you know that H plus ions means acidic behavior. But if the solution is basic, it means there is no H plus ion. But let me explain you that if you are having a solution with pH 2, it means acidic. It means acidic. It means neutral. It means basic. It also means basic. Okay. So if we have this one, so the OH ion concentration will be 10 raised to the power minus 12. The pH is 2, then the H plus ion concentration will be 10 raised to the power minus 2, and the OH ion concentration will be 10 raised to the power minus 12. Okay, you understood?
Yes, sir.
Similarly, if we have this 3, then if it is going to have pH, if pH is 3, then the concentration of H plus ion will be 10 raised to the power minus 3. Got it? Then here will be, this will be 10 raised to the power minus 11.
Minus 11.
So when you add this, they will give you 10 raised, because bases are same, then power will be added. Okay. So here will be 10 raised to the power minus 7, 10 raised to the power minus 4, 10 raised to the power minus 2. Okay. So if we are having a basic solution, then in that solution, let's just take an example of this one. Take an example of this one. If we are having 10 raised to the power minus 12, the pH is 12, then the H plus ion concentration will be 10 raised to the power minus 12, and OH ion concentration will be 10 raised to the power minus 2. So this means that OH ions are 0.01 and the H plus ions are 0.1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So this is very, very less value as comparison to this one. Okay, so this solution is going to have more OH ions as comparison to H plus ions. So the solution is basic. And at neutral condition, the both are going to have the same 10 raised to the power minus 7, 10 raised to the power minus 7. The both are going to have same. So that is at pH 7, the solution is neutral. Got it? So if the question comes to you that do the basic solutions also have H plus signs? So yes, basic solutions, write it down fast, also have H plus ions, but it is very less as compare to OH ion concentration. Yes, you can explain it. For examples, Ashwin, wait for 1 minute. Okay, I'm just going to complete this answer. Okay.
Yes, sir. Yes, sir.
So if you are having this one, yes, the basic solutions also have H plus ion because, for example, you can explain. For example, if the pH of the solution, is 12, then the H plus ions concentration is 10 raised to the power minus 12 mole per liter, but OH ion concentration will be 10 raised to the power minus 2 mole per liter. Okay. Note it fast. I'm going to give you the homework on the same topic and you have to solve the questions, okay, and use your mind, okay? Got it? Abir, Shuaib,
Yes,
Rohit?
sir.
Tejasvi, you also?
Yes, sir.
Okay. So we have basic solutions also have H plus ions, okay? So that is if
Noted, sir.
pH is 12, then the H plus ion concentration will be 10 raised to the power minus 12, but the OH ion concentration will be 10 raised to the power minus 2. And that is very, very large as comparison to this one, okay? 10 raised to the power minus 2 has a very big value as comparison to 10 raised to the power minus 12, okay? So that's all for today. We'll discuss this one in the next class. And Abir, you need to join the half an hour class at 9:30, okay?
Yes, sir.
Or you can watch it the lecture on the portal, okay? So that's all for today. We'll meet you in the next one. So you can leave, dear students, okay? I have to find the same link for the next class, okay?
Thank you, sir.
Thank you. Tam. Hello, Ashwin. How are you? Can
Good
you
evening,
put
sir.
on your camera?
Yes, sir.
Okay, so Ashwin, today we're going to discuss today's physics class. Okay, so which chapter would you like to study today? Because we are just studying in the batches that we are studying the light chapter. Okay, the reflection and refraction portion. So I think that's the same chapter we're going to you are going to have in your examinations. Okay, so should I start with the light?
Yes, sir. Right. Yeah.
Okay, specifically light has means let me explain you the your topics. Okay, that is so first of all, light chapter. In the light chapter, what we generally study, we generally study two types. Light is divided into two portion in the 10th standard. One is the reflection by mirrors, okay, and next one is refraction, bending of light from one medium to when it passes from one medium to another medium. Okay, so here we will study about the image formation by concave mirror, plane mirror, and concave mirror, convex mirror, numericals on the same topic, okay, and laws of reflection. And in the refraction portion, we are just going to study in the refraction, what we're going to study, image formed by lenses, image formed by concave and convex lens, The section we will study the refractive index, and that one is refractive index, and the last topic that will just